Hello, welcome back to WWC channel. Today I would like to invite a special guest to learn the lesson with you. So who is she? She is called Little Pinky, the girlfriend of Yin Chen. So now she is coming. Hello! So Little Pinky, do you know what we will learn today? I don't know. So if you don't know what you will learn today, so please stay in tune and also stay in tune and see what we will learn today. Hello boys and girls, today I would like to talk about a simple concept. It's called the number of factors. So what's the meaning of number of factors? So you should remember what's the meaning of factors. Factors are actually the numbers that can divide such an integer. So we call them factors. So now if I want to talk about how many factors of a number, then actually it's not a very difficult thing. Because you may think about, oh Mr. Wong, I just take a number, for example, I say 12. So I can easily list all the factors because this one you will simply have 1, 2, 3, 4, 6, and 12 itself. If I just talk about the positive factors. Yeah, so actually you can see that now you have 6 factors here. So actually today I would like to focus on this number 6. So I may take another example. For example, this time I may take another number, such as if I say this time I take the number 21. Then you can easily list out also, because 21 you have 1, 3, 7 and itself 21. So actually now we will have the number 4, which represents the number of factors of 21. This one. But actually, it is not easy if the number is big. For example, this time, I give you another example, like now, I say, I give you a number 252. So if I give you the number 252, so you may think, oh, Mr. Wong, I can list 1, 2, 3, 4, and so on. But actually, it is not effective because sometimes you may forget to list some factors of the original number. Just like what you did in your final examination in your Form 1 paper. So if I want to list all the factors and also we want to know how many factors there, how can we do it efficiently? So now, I would like to introduce a concept. But before I want to introduce a new concept, now I would like to give you one more definition. Is that now I want to define the power 0. So what is the meaning of power 0? Power 0 means that I want to define the power as a 0 on the number. For example, if I say 2 to the power 0 and 3 to the power 0 and so on. Now, we define 2 to the power 0, 3 to the power 0, or actually every number 0. So here we want to restrict that n should be not equal to 0 because it's not meaningful to divide 0 to the power 0. We will all say that all power 0 is 1. So please keep in mind this definition because when you go to Form 3, your math teacher would explain this concept to you in more detail. So now just keep in mind this concept first. Now, we go back to take a look to an example. For example, we say 12. So if you still remember, we say 12, we will have 6 factors, which are 1, 2, 3, 4, 6, 12. Now, if I now take a look on these 6 factors, and also we consider the factorization of the prime factors of these 6 numbers, then we can see something. So what is the meaning of factorization of prime factors? So actually this one is just like index notation. How can we do it? So I just give you a very quick example here. For example, we say 6. I can say this one is 2 times 3 because it is 2 times 3 as a product of prime. And also we can put the index. For example, I say 2 to the power 1 and 3 to the power 1. So actually this one is called the factorization of prime factors of 6. So we can do for all factors. For example, 12, original number, we will also have 2 to the power 2 times 3. or we write precisely, we say 3 to the power 1. Then now we can list all the numbers. Such as here, 4 you have 2 to the power 2, 3 you have 3 to the power 1, and so on. So because we have already defined the power 0, so now we can do one more thing, is that I can make power 0 here. For example, I say 1, I can say 2 to the power 0, and 3 to the power 0. And so on, you can have this one, this, and this. That means that actually, you can see every factors. Even I can say the even number 4. I can also express it as the product of 3. But not only 3, but it's 3 to the power 0. It reduced to 1, so it's still okay to say 2 to the power 2 to 3 to the power 0. So you may not observe something here. But now, if I change the form of this one into this way, then you can see something. So how can we represent those 6 factors again? Now, I choose using a table. So what is my table? The table means that now I define the things in this way, which is I say this one is 2 to the power 0. Here you have 2 to the power 1, and also you have 2 to the power 2. On the other hand, for the column wise, we can have 3 to the power 0 and 3 to the power 1. So if we define them, they are multiplying together to have the number inside. Then actually you can easily see that now I can fill in all the numbers, including 1, here you have 2, and 4. Similarly, you have this one is 3, 6, and 12. So you can see in this table, all the factors are listed. And there will be no more factors of 12 outside the table. What is the reason? Because actually you understand that number 12 is 2 to the power 2 times 3 to the power 1. So all the factors should have 2 or 3 as the factors. And it cannot be any other more. And also if I list all the powers of 2 and 3 and you make them combinations, then you can easily see that all the combinations are listed by using the table here. So here should be all the factors here. So using the table, you can easily to get the number of all the factors. So you can also know that the number of factors will be 6. Because altogether there are 6 numbers here. So I don't know whether you can observe something here. But actually I observed something. Is that now if I want to find the number of factors, I can also think about that how many numbers in the row and the column. Now you can see here 2 is e to the power 2, including the number 0. Here altogether we have 3 numbers. Similarly, here if I take 1 in the 3 to the power 1 here, so actually here you have 2. That means that actually now I can know that how many combinations of the 2, because you have 3, because the power 2 is 2 here, so you have 3. Similarly, you have 2 here. And if you can observe that 3 and to these 2 numbers, if they are multiplying together, it is equal to 6, which is the same as the number of factors of 12. That means that actually the formula of finding the number of factors is simple. So what is the formula? Now I want to generalize the number of factors. Now, I take a number, if I say the number is n, I can always express the n as the product of prime, or we simply say factorization of the prime factors. So we assume that the factors are P1, P2, 3, 3, and so on, because we don't know how many factors are actually there. So I just assume that they are altogether m factors. So we list as P1, P2, P3 as Pn. And for each of the primes, it has its power. For example, I say P1, you have A1 power, and then you have A2 power, A3 power, and then so on. The last one, you have AM power. So it's just like they are multiplying together. Then we will say that now the number of factors are simple, because what you need to do is to consider how many powers are there and what are the powers. But don't forget that because we start counting from 0, not 1 itself. That means that for every power, we have to add 1, such as A1, you add 1, A2, you add 1, and then so on. Until the last one, you have to add 1 also. Then what you need to do is to group them, and then to multiply them together. Because if you still remember the table before, it's just like we multiply them together to have all the combinations. So actually the formula would be simple as A1 plus 1 times A2 plus 1, and then so on, until you have added the last power by 1 as the product. So here would be your formula. So now we can apply this formula to find the number of factors very fast. For example, now this time I take a number. For example, once again I say 180. So how do we know how many factors are there? So what we need to do is simply that we have to get the prime factorization of this number. Now how do we do it? So we can simply do the short divisions, or you can use a very fast method, such as you separate the number into some products. But anyway, so I just do the short division very fast. For example, you have 2. So how many 2 here? You have 2 only. So we have 45 here. So we have to start with another prime number, for example, 3. So this time, how many of you have here? You have also 2. And the last one, you have 5. So because we have 2 to the power 2, 3 to the power 2, and 5, or simply we say 5 to the power 1, then we can conclude that the number of factors of this number should be simply equals to 1. So it should be simple to 2 plus 1, which is 3. And here, 3 also. The last one, you should have 2 multiplying together. To have your final answer is 18. So you can see, even I do not list all the factors of 180. I can still know the number of factors of 180 very fast by using this method. So before I end this lesson, so I would like to leave a very interesting questions for you to think. The interesting question is that now, using the formula, I can also know that some special properties of the number. For example, now I say I give you a prime number. For example, 17. Then you know that 17 is a prime number. That means that it has only a prime factor itself, is itself, 17. So you can easily see that because 17 is a prime number and it just only have itself, and also itself should be power 1. That means that the number of factors should be 2. Because it's just like 1 plus 1, which is 2. So now you may ask yourself whether every prime number has only 2 factors. But I think that the answer should be very easy, because it should be yes. Why? Because you know the definition of prime number. Prime numbers should have only 2 factors, which is 1 and itself. So you can see by using the formula, you can verify 2 also here. Now, the questions that I would like to think is that, using the formula, can't you find all numbers, or we simply say all integers? So what are the integers? So I want to have those integers have odd number of factors. So what is meaning of odd number of factors? Odd number of factors means that the total number of factors should not be even number, it should be odd number. So if you still remember, 12 is not the number we want to consider, because if you still remember 12, you have altogether 6 factors. Such as 180 we said before, we will have 18 here. So actually you can see these 2 numbers are all even, but not odd. So try to think whether we have odd number of factors, and what numbers will have this property. Answer me, and I give you the prize. So boys and girls, I hope you enjoyed today's lesson. See you soon. Goodbye.